everyone. This is Nate, and in this file contains our hash table. So the initialize method, this sets the size of the bucket and initializes the elements into an empty list. So for every bucket that there's going to be an empty list, and that is done using this line right here. The assign buckets method loops over the elements and assigns them to a bucket. This is done by using the built-in hash function to get the index of the bucket, and then the modulo operator is used to map the hash to a bucket. The getValue method gets the values of a key by hashing the key and finding the index of the bucket. So the for loop within the getValue method iterates over the bucket to find the key and then returns that value. The delete value method computes the hash of a key and then finds the index of the bucket. The for loop within the delete value method loops over the bucket to find the key and then it is deleted. And then the dunder stir method that returns all the elements of the hash table. So in our test.py file, I have the populations of the five most populous countries according to worldometers.info. There's the URL right there. But most importantly, I also imported the hash table from the hash table file. So what you want to do to initialize the hash table is create a variable and initialize hash table right there, and then pass through the data. In this case, it would be our population's data. And then getting the value of, let's say, India, for example, we would say print pop hash get value India. Then let's say we want to delete a value. In this case, we are deleting Indonesia from the hash table. So we would do that by saying new hash and then assigning it to pop hash dot delete value, and then we pass through Indonesia and then print new hash. Let's run the file to see if Indonesia is deleted and if we get the value for India. So looks like we got the value for India, and it's confirmed that Indonesia is no longer a part of the population's hash.
How's it going? I'm going to help you visualize a hash table here. Suppose we have a hash table the size of 5, and the key is the last digits of the ID of these people. Our very simple hash function today can be key mod table size. We have some different things that we can do to manipulate this data. We can insert Adam right there, which go to index 0 with Alice, and we can store these two as a linked list since there is a collision there. We could retrieve, which is the main reason of having these hash tables. If we look up key 37, we can retrieve Charlie there. We can delete data as well and give Adam his own space right there. Another way to visualize this is a binary search tree. So each node in the binary search tree holds key value pairs, allowing for order storage. We could look up operations 37, that goes to index 2. It can be found as the right child of 12 there. We can insert new elements there, and since 17 is in the middle of 12 and 37, it'll become the left child of 37. As well as this, we could delete nodes. Delete a node 12 there. We can replace 12 with 37 and then store that as is with 17 as the left child still. I got some real world applications here. So we got some databases, indexing for quick lookups and large amounts of data, which is the main reason of these hash tables, allows large amounts of data to be quickly looked at and hashed. Gets routers and DNS servers, which can map IP addresses to corresponding destinations. and then caching, which can store frequently used data in memory, and this allows the removal of having to use slow computations when we don't have to. This can just bypass some of this added time and excess wear on the computer and save everybody some time. So, yeah, we got some real world applications here, and thank you.